Hello, my loves. Today we are working on unit cubes and solid figures, lesson 11.6, and I'm adding 11.7, which introduces volume. So 11.6 is all about unit cubes and solid figures. And our standard is that I can recognize volume as an attribute of solid figures and understand concepts of volume measurement. So we talked about this yesterday. We are looking for the area of a flat figure, of a two-dimensional figure, of a plane shape. But when we have a three-dimensional figure, those three dimensions are length, width, and height. So a unit cube has a length, a width, and a height. And you can build rectangular prisms and other solid shapes using unit cubes. Here's our objective for today. I can find the volume of a solid figure by counting unit cubes. Our essential question: how can counting the unit cubes help you find the volume of a solid? Here are our steps, our lead measures. We're going to unlock the problem for 11.6 and 11.7. And we're going to practice identifying, categorizing, and finding the volume of irregular solid figures and rectangular prisms. And then we're going to go over to IXL, and there's a really cool activity where you identify 3D figures from different perspectives. Now, this is something kind of new, different perspectives, and I'm really excited to share that with you. All right, and just like I told you I would, I changed this. Your math grades are still your 2 iReady teacher-assigned lessons and your minutes. So first, go to those 2 iReady teacher lessons, get those done, and then you can finish up your minutes with your regular path. So 50 minutes, you'll get 100%. Plus, you'll get perfect attendance for the week if you also do those 50 minutes of reading. I emailed a couple of your parents because I noticed that you guys weren't getting those minutes in. You don't want to be counted absent. So make sure you do 50 minutes of math and 50 minutes of reading. All right, here we are at Unlock the Problem.
You can build rectangular prisms using unit cubes. How many different rectangular prisms can you build with a given number of unit cubes? A unit cube is a cube that has a length, width, and height of 1 unit. How many square faces does a cube have? 1, 2, 3, 4, 5, 6. A cube has 6 square faces. All of its faces are congruent. How many edges does it have? It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. The lengths of all its edges are equal. Now let's build a rectangular prism with 2 unit cubes. How many faces does this rectangular prism have? Think, when the 2 cubes are pushed together, the faces and edges are pushed together to make 1 face and 1 edge. It has 1, 2, 3, 4, 5, 6 faces. How many edges does the rectangular prism have? It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. Now, build as many rectangular prisms as you can using 12 unit cubes. In cubic units, what are the dimensions of each prism? They are 4 times 1 times 3, 6 times 1 times 2, 3 times 2 times 2, and 12 times 1 times 1. So with 12 unit cubes, you can build 4 different rectangular prisms.
Okay, so let's take a look at these the volume that they're talking about. So here, it's 4 times 1 times 3. And the reason that they're saying it's 4 times 1 times 3 is because we have a base of 1, 2, 3, 4. We have 1, which is this width right here. So the length is 4, the width is 1. That means it's 1 deep, and the height is 1, 2, 3. So we have 1, 4, and 3. That's where we get this expression from. So here we have 6. 1, 2, 3, 4, 5, 6 is the length. The width, how wide is it? It's only 1 unit wide. And then the height is 1 and 2. This one's a little different because we have a width of 2. It's 2 deep. And it's 2 units high and 3 units long.
You can build solid figures and compare them by counting the number of unit cubes. How many cubes make up each figure? Let's begin with this figure. How many cubes make up this figure? This figure is made up of 5 unit cubes. How many cubes make up the next figure?
Well, let's count them. How many did you get?
This figure is made up of 4 unit cubes. Which figure has more unit cubes? The first figure has more unit cubes. Next, you can use 10 unit cubes to build 2 different solid figures that are not rectangular prisms. Here's one figure. Now, build another figure. How are the models the same? They are built with the same number of unit cubes. How are the models different? They are different solid figures. There are many different solid figures you can make with 10 unit cubes that are not rectangular prisms. You can count the number of cubes used to build this solid figure. How many cubes are used?
All right, well, I've got 1 cube, 2 cubes, 3 cubes, 4 cubes. Now this is still number 1. This is also still number 1. That's 1 cube. This is also cube number 2. Make that 2 better. This is the side of cube number 3, and you can't see the rest of cube number 4. Back here, we've got cube number 5, and this is also part of cube number 5. This would be cube number 6. This would be cube number 7, and you can't see it, but there's a cube number 8 underneath number 6. So you see how there's these 4 cubes here? And we're going, even though, I guess there could be like a missing piece, but they're not going to do that to you. If you see a solid shape here in front and there's another row behind, you're going to have to assume that it's the same. So all together, we have how many unit cubes? 1, 2, 3, 4, 5, 6, 7, 8.
Correct. There are 8 unit cubes. Now, how many cubes are used to build this figure?
All right, let's see. How many did you count?
Correct. There are 6 unit cubes. Now, let's practice with the personal math trainer.
All right, we're going to get out of this guy. And now we're going to click over to understanding volume.
Let's find the volume of rectangular prisms. Each unit cube is equal to 1 cubic unit. We can add the total number of unit cubes within this first prism to find the volume. There are a total of 10 unit cubes. If each cube has a volume of 1 cubic unit, what's the volume of the rectangular prism? The prism has a volume of 10 cubic units. Let's move on to a second prism. We can also discover the volume of any three-dimensional figure by finding its length, width, and height. To find the volume, start by finding the length and width of the base. Each unit cube has a length, width, and height of 1 centimeter. The length of the base is 3 centimeters. The width of the base is also 3 centimeters. To find out how many unit cubes are in the base, multiply the length by the width. How many centimeter cubes are used to fill the base? 9 centimeter cubes fill the base of the prism. How many layers are in the prism? There are 5 layers in the prism. That means the prism has a height of 5 centimeters. If there are 9 cubes in each layer, and the prism consists of 5 layers, how many centimeter cubes fill the prism? Think, 5 layers times 9 cubes in each layer equal how many cubes? 5 times 9 equals 45. So 45 centimeter cubes fill the prism. The volume of the rectangular prism is equal to 45 cubic centimeters.
Okay.
Volume is measured in cubic units, such as cubic centimeters, cubic inches, or cubic feet. The volume of each cube is related to the size of the unit of measurement. Which has a greater volume, 1 cubic inch or 1 cubic foot?
Well, let's think about that. Which is bigger, an inch or a foot? A foot is bigger, and you can clearly see using these cubic blocks, these cubic units, this one's quite a lot smaller. You know what I'm thinking? If there are 12 inches in a foot, I'm wondering if 12 cubic inches will fit inside 1 cubic foot.
Feet are greater than inches, so 1 cubic foot would have a greater volume. Compare the volume of the prism in cubic centimeters, cubic inches, and cubic feet. Remember, for a three-dimensional figure, volume can be determined by multiplying length, width, and height. What's the volume of the prism in cubic centimeters? Find the product of 5, 4, and 2.
So what they have here is when it says V equals 5 times 4 times 2, this right here is the formula. And that might sound familiar to you because when we had our focus offices, I had that little little cheat sheet from FSA, and it had the formula for area and it had the formula for volume. And the formula says that volume equals length times width times height. Sometimes you'll see the formula say that volume equals base times height. And that's what they were doing here. First, they were finding the base. 5 times 4 is 20. And then they multiply the base times the height. Let's see what the answer is.
The prism has a volume of 40 cubic centimeters. The numerical value for the volume of the prism in cubic inches and in cubic feet is also 40. Although each unit may contain the same number of unit cubes, the volume of the prism depends on the size of the cubic unit. Would a volume of 40 cubic feet be greater than, less than, or equal to a volume of 40 cubic inches?
Remember back in science class when we were talking about volume, and what volume is the amount of space something takes up. We were talking about the weight of something or its mass, right? And the volume is how much space it takes up. So that volume goes along with math and science.
A volume of 40 cubic feet is greater than a volume of 40 cubic inches. Find the length, width, and height of the prism and determine its volume. Find the length, width, and height of the prism. Type the answers and then click Check.
All right, so here is that perspective that we were talking about. In another picture, they had this prism turned sideways, turned the other way, where this side was considered the length. But all they did was twist it and facing towards us. Now they're calling this side the length. And it really doesn't matter. I could take this prism and turn it up and have it standing up like this. It really doesn't matter which one you call the length, which one you call the width, or which one you call the height. As long as you multiply all three of those dimensions together, all three of those dimensions together, that's how we find the volume. So what is that length? Let's see. Shout it out to me. How about that width? I heard someone give the wrong answer because they're trying to be funny. All right, let's go over it again. The width is get my crayon in there. 1, 2, 3, 4. We are not counting how many boxes. We're just counting the width. We're counting one dimension. Do you guys believe me when I say I heard someone call out the wrong answer? Well, I did, because my ears are that amazing. What about the height? Thank you. Good answer. And let's check. Well, actually, before we check, why don't you go ahead and use that formula of volume equals length times width times height. So we said the length is 3. Plug it in, plug it in. I'm plugging in my numbers. What's the volume? Do you have it? Let's see if you're right.
That's right. The length is 3 centimeters, the width is 4 centimeters, and the height is 2 centimeters. Now, select the correct volume.
All right, you got the answer? Let me know. Yes.
That's right. The volume is 24 cubic centimeters. Find and compare the volume of each prism. These two prisms have the same length, width, and height, which means they have the same volume. Select the volume that represents both prisms.
Okay, we know that volume equals length times width times height. Now I'm going to plug in those dimensions. I've got volume equals, here's a 4, 1, 2, 3, 4, times 1, 2, 3, 4, times 2. And 4 times 4 is, yep. And what's 16 times 2? 32. Absolutely, it's 32. You could also do 4 times 2, which is 8, and 8 times 4 is 32. So you can use the commutative property to make the multiplication a little bit easier for you.
That's right. The volume of each prism is 32 cubic units. One prism has a volume measured in cubic feet. The other prism has a volume measured in cubic inches. How do the volumes of the prisms compare? Select greater than, less than, or equal to.
Now, here's a problem where looking at the pictures, you're not going to find the answer because they're completely the same. The only difference is that they are telling you that these are feet and these are inches. So you have to read. You have to look very carefully at the information they're presenting you with. 32 feet is not equal to 32 inches. 32 is equal to 32, yes. But feet to inches, nope. It's going to be greater than.
That's right. 32 cubic feet is greater than 32 cubic inches. Now, let's practice with the personal math trainer.
We're going to practice with something else. We're going to practice with our Go Math textbook. And we're going to go to page. I was just there. I thought I was just at that page. 400. Nope. Not that one. Here it is. 465. 465. That's the one. Okay. Let's take a look at what we have here. And let me make this a little bit bigger. Okay. We got that going? Perfect. All right, number 1 says a rectangular prism is made up of blank unit cubes. So count the number of cubes used to build each solid figure. I'm going to use a blue color. Okay, so this one, 3 unit cubes. How about number 2? Count them with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 cubes, and the reason there are 15 cubes is because this and this all belong to the same cube. For instance, over here, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. This side, this is the side of cube 1, and that's the top of 1. This is the top of, there you go. That's the top of 2, the top of 3, that's the top of 4. This is the side of 5, and that's the side of 9. So be careful and don't count those sides as a cube. We're counting the full cube because it's a 3-dimensional figure. So we're at 12 here. All right, let's count this one. 1, 2, 3, 4, 5, 6. I know that there are 6 here. So how many are going to be behind? Another 6, absolutely. So 6 and 6 is going to be 12. And these are called regular prisms. So they're rectangular prisms. They're a regular shape. But these are not prisms because they're irregular shapes. So we have regular and irregular. Let me move down. And clear. All right, let's take a look now. How many unit cubes? 5 unit cubes, right? We're not counting those sides. We're counting the full cube. This is what we're counting. We're not counting those faces. We're counting the whole cube. How many here? 6. All right, tell me number 7. Don't just wait for me to tell you the answer, count them. The answer, look, the answer to number 7 is 7. Awesome. All right. Let's flip over to the next one, which is page 469. Okay, so now we're talking about, instead of just counting those cubes, which you can continue to do here, but it gets to be a little bit challenging when you have large figures like this. So instead of counting all of these cubes, what we can do is we can use the formula. The formula for volume. And that formula is length times width times height. So let me get this. Let's say this is the length. We've got 4 times, what's the width? 4. And the height is 3. So we need to multiply these numbers. And this is where I would like you to get paper and pencil and practice this over and over and over again. So we know that 4 times 4 is 16. And now we need to multiply 16 times 3. Well, I know that 3 times 6 is 18. And I'm going to regroup, carry that 1. And 3 times 1 is 3, plus 1 is 4. So we're going to have 48 cubic what? Well, they're in centimeters, so it's cubic centimeters. And it's really important with measurements to talk about the measurements very precisely. Because if you're going to Home Depot and you measured something in cubic inches, and you tell the person at Home Depot that you need feet, you're going to be getting charged a lot of money for something you don't need. Now, remember I said the other formula for volume was base times height? And the reason that they did that is because they're telling you to find that base first. And if you remember yesterday's lesson, the Willy Wonka lesson, first they filled in the base. And the base is 3 times 2. That's the base. That's a 2 right there. That's the base. And then we're going to multiply the base times the height. So 3 times 2 times 4, it's exactly the same. And 3 times 2 we know is 6 times 4. And what is 6 times 4? 24. So it's 24 cubic what? Inches. That's right. Cubic inches. Okay, so here's what I want you to do. While I'm working these out, I want you to pause the video. Pause it, do the math yourself, and see if you get the right answer. Because then you can just hit unpause and check your answer with me. All right, so let's write down the formula, length times width times height. All right, go ahead and pause the video and do the math. All right, I did mine, and I put my numbers a little bit out of order, didn't I? Because using that commutative property law, it really doesn't matter which order you're putting them in when you're multiplying. And the reason that I did that is because 3 times 2 is 6. And 6 times 6 is 36, and it's cubic feet. Did you show your work? Did you show your thinking? Or did you say, oh, I just did it in mental math? Please don't do it mentally. I want you to do it on paper, because remember when we're first learning stuff, they give us easy numbers. But then when you go to practice on IXL, or when you go to practice on iReady, It's going to be more like 32 times 16 times 4. And you really need to get in the habit of writing down these problems and going step by step by step. Okay, number 4. I'm going to use base times height for this one. So go ahead and pause the video and check your answers. And I know that my base is 5 times 4, which is 20. And 20 times my height, I get 60. 60 cubic inches. It's really great that we're doing this on videos because you can pause and rewind and watch this as many times as you want. And you can't really do that in the classroom. The only time that we really get a chance to revisit it is when we're doing our small groups, or if you ask me questions, but you guys don't like to ask questions. I wish you asked more questions. And you know what? You're allowed to ask questions even now. I encourage that. Send me a message. Tristan emails me from the webpage. When you go to my webpage at AGA Broward, on the left-hand side, you can click the button that says email, and Zoom, email me, and I'll answer you. So you can always ask all kinds of questions. You can send me screenshots of what you're doing online. You can show me a picture of the math that you're doing. And if you're stuck, show me a picture and say, hey, help me through this. I'll be happy to walk you through it. All right, let's look at number 5. Again, we are finding the volume and then we are comparing those volumes. So let me find the volume here. 4 times 4 is 16. My base is 16. And 16 times 2 is 32. So it's let's get rid of that one, get rid of that too. There we go. 32 cubic centimeters. That's an important clue. And this one, I've got 16. Oh, look, it's the same numbers. I don't have to do the math. 32 cubic inches. Well, if I'm comparing a centimeter and an inch, I know that an inch is bigger. So since the numbers are the same, the inches are going to be bigger, greater. I'm gonna go down. There we go. Okay. Let's try 2 more. Each cube is 1 cubic feet, 1 cubic feet. And let's see, are the numbers the same like before? Oh no, they made it challenging. They're different. Okay, so I've got length times width times height. My length is 9, my width is 4, and my height is 3. I know that 9 times 4 is 36, so I'm going to do 36 times 3. 36 times 3. 3 times 6 is 18. Going to regroup that one. And 3 times 3 is 9, plus 1 is 10, so I have 108 cubic feet. Now let's look at this one. I have a base of 40, because 8 times 5 is 40, and I multiply that by 2, and I'm going to get 80. So is 180 cubic feet greater than, less than, or equal to 80 cubic feet? Oh, look what they did. They're both in cubic feet. So now I have to look at those numbers. Well, we know that 108 is greater, yes? Perfect. Okay, back at our Common Board lesson, I made for you a little slide comparing the rectangular prisms and irregular solids. Now remember, we talked about them. They're still made of those unit cubes, but rectangular prisms are very easy to do length times width times height. Irregular solids, not so easy. All right, so for instance, this rectangular prism, the first one here on the left, We could count the unit cubes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Or we could say, well, there's 3 cubes here, and there's 5 cubes here. 3 times 5 is 15. So we could very easily do that. For this rectangular prism, I could multiply 3 times 4. Because it's a rectangular prism, every row is equivalent, and we're going to get 12. Now this one is going to be a little bit different because now we're talking about 2 deep. Now we have to do the length times the width. Here's my width, and then the height. So my length is 3, and my width is 2. So 3 times 2 is 6, and what's 6 times 2? 12. Yeah. So basically, it's like saying 2 times 3 is 6. And then if I have 6 in this first, in the front row, I'm going to have 6 in the back. And what is 6 plus 6? That's 12. Now for the irregular solids, we can't do that. We can't multiply length times width because the rows are not equal. So here we have to count 1, 2, 3, 4, 5. Here we have to count. I have length times width here. If I cut this off, I would have a prism, wouldn't I? And I could do 2 times 2 is 4, and then add that extra little piece of 1 times 2. Or 1, 2, 3, 4, 5, 6. All right, count this last one. Tell me what the answer is. Very good. It's 7. Awesome job. Okay, lastly, here we are at IXL. And this is a fun activity of 3-dimensional figures viewed from different perspectives. So I mentioned that before, that different perspective, it's all how you look at it. There we go. So if you look at this figure, from the top, so they're showing us that 3-dimensional figure, but I want you to imagine kind of just moving your head and looking straight down. What would you see straight from the top? You're going to see this top view. How about this one, from the front? Now, I'm not sure if they mean this is the front or if this is the front, but let me look at my options. This one definitely can't be it because I don't see this anywhere on that picture. They didn't give me this as an option for the front, so I'm guessing they think this is the front. All right, we got it. Now, when we look at this from the side, do we see 3 or do we see 6 faces? I see 6 faces from the side. Okay, oh, look at this one. When we look at it from the top, this is the top, it's going to look like that. How many faces do you see on the top? 1, 2, 3, 4. I see 5 faces. Okay, when you're looking at it from the front, well, I'm guessing this has to be the front. That would be the top, right? Now with IXL, the problems get more challenging as you go along. So if you want to continue with this, go ahead and sign on to IXL, or find some other fun activity on IXL that you can practice with. All right, and I'll see you next time. I love you. Bye-bye.